Hey everybody, Spoonfed here, and we're gonna do Decryption Mission level 2, which has this string, and it's base64 encoded. Maybe a lot of you have seen base64, but don't know exactly how it works. Well, on Wikipedia there's a excellent example that shows you everything from step 1 to the last step for the encoding part, and how you can translate it back, as it were. Basically what it does is it takes the original text. In this case we're just going to do man. It will get the letter, we'll get the ASCII value of that letter, and then print that out as a bit pattern. Now you can see that I selected 2 more than is necessary, because this is usually an 8-bit, another 8-bit, and another 8-bit. The fact is, base64 uses 6-bit patterns because they have a maximum of 64 different binary values, meaning base64. So you grab the first 6, that is equivalent to a number 19, and that is the letter T, because it has its own index, and its own index is, well, from A till Z in uppercases, from 0 to 25, which is normal because it's 26 numbers, and from 26 to, where are you, there, 51, you have the smaller letters, and then from 52 to 61 there are the numbers, and then there's a plus and a slash. So you can also have like an is sign, like this, equals 2 sign. So that's why man is translated to TWFU. Now you can memorize all these things, of course. That's one way to do it. Then you can read this backwards, so you know that V is equal to 21, and then you know that 21 is a bit pattern, and then that bit pattern corresponds to a ECI value, and then you know what letter that is. That's a possibility. What you can also do is grab this, no, not select all, copy it, creeper.com is your friend, say decrypt, copy. That's it. That is actually it. And so basically this whole thing corresponds to a 6-bit, or no, sorry, an index number that corresponds to a 6-bit digit, but all of those 6 digits put together produce an 8-bit digit from left to right, of course, and then that 8-bit digit, or 8-bit sequence I should say, corresponds to an ASCII value, and that corresponds to the letter that you want to have. In this case, that one. But this TO corresponds to that VG. It's not that the V only corresponds to T, because that's impossible, because only the V produces a 6-bit sequence. So you need to have this one to produce the 2-bit sequence that G produces. So that's why you sometimes, well, you know, you normally have way more base64 characters than you have these ones. So I'm going to submit it, and we have done it. Yeah, here it is explained the same like what I said, but I find this to be a little bit more simple to understand, because you can nicely see the steps that are done, and you can also, of course, code your way backwards. So you'll say, okay, well, the first thing we need to do is we're going to make an index of these numbers. You can swap these around in your own index, of course. You can make your own base 64 index table. It doesn't matter. If you want to say that R should be equal to the value of 1, you know, go for it. But that will mean that you have a custom built base 64 one, and that will be a little bit harder to crack, as it were. But just take this table. You're gonna say, okay, well, U is equal to 46. Then we need to transfer this number 46, and I should start on the left, by the way, sorry. You're gonna take T, then you're gonna take 19, and you're gonna put 19 as a number up, but a 6-bit number. So only that one, and then another 6-bit number, and another 6-bit number, and another 6-bit number. Then you're gonna say, well, read that, whatever bit strings come out of there, convert it to 8 bits. So chop it up into 8-bit pieces. We'll get a number, and then print out the number, or the character that corresponds to the ACI number. So that's it for base 64 encoding, and usually it is indeed done for binary data, but now it's also used for passwords and the like, and whatnot. So yeah, have fun with decrypting base 64.